Hi, hello everyone. Thanks so much for joining me today. If you're a returning subscriber, I really appreciate your support. And if you haven't subscribed, please consider subscribing to enable me put out content like this. Today I'm really excited to delve into my second video in my Neo4j series. And today I'll be talking about a more complicated relationship matching with Cypher query. We'll also look at string matching, pattern matching in general, and I'll be covering regular expressions. Now there's lots of things we could be talking about which are covered in the official documentation. I'll just show that to you. I've also included a link to this in the description of this video, so please feel free to check that out. You can see the where clause here that has everything you need to know about pattern matching. Essentially, there's regular expressions and all of these things. So I'll just be covering a small subset of this. I'll be looking at regular expressions essentially, and just showing you how to put this into practice in a real world scenario. I have my database set up in Docker. I will not go into the nitty-gritty of that today, just because I want to cover that in a full pipeline, which I'll be building in a subsequent video. So what I have today is a database which I've set up, like I said, in Docker, and this data is data from Amazon. It's data that has to do with metadata of books and also review data. So essentially you have a review ID here, a user's reviewing a book, that's the name of the reviewer, and this is a helpfulness score. Basically it's how helpful did you find this book, or how many people found this review helpful of the total number of people who have reviewed this book, basically. So this is the review text. There's also the time when this was reviewed in Unix time. So there are lots of things in here, lots of data fields in here. And for the meta book data, this is a unique identifier. It's called as in. That uniquely identifies a book. And there's the title, there's the image URL, there's related. So essentially related has certain relationships, let's say. So also bought would be users who've also bought this book, or rather I should say books that were bought alongside this book. Essentially that's what this is. So these were books that were bought after viewing this book. So I'll convert all of these to relationships, like you can see here. And when thinking of graph databases, you have to think about how to model your graph database, because essentially you could have data that's in this format, or even like CSV or whatever, and you want to build a graph database, and then you need to be thinking about how to model your data such that you can really query important relationships from it. So in my case, I've thought about the reviewer as an entity, which is why I've created a node for reviewer. So I've said this represents a user who writes a review, and that's good. And then you have the book entity, of course, represents a book, which is a product. And then you have a category as well. So you have a book category. So a book belongs to a certain category or a number of categories. And also you have, for the relationships, I have has subcategories. So what I'm doing here is, in modeling graph databases, in some cases, when you're dealing with categories, if you have a number of categories and many subcategories, you maybe want to have a has subcategory relationship, because it makes it easier to find patterns in this way. So you're treating, I could treat subcategory as a property of category, right? But there's many of them. So I want to see how each category relates to the subcategories, and then you can see that we can build more complex relationships from that and find deeper insights from that. So that's what I've done here. So for the places where I've seen, sorry, this is not the ideal example because you don't see subcategories in here, but in my data, in my database, I definitely have subcategories. And once I see a category and an associated number of subcategories, I'll create a has subcategory relationship for each subcategory. And then you can see that from the node category to that subcategory is one relationship, and it has as many relationships as there are subcategories for a category, if that makes sense. And the action, the review action itself has a relationship. Of course, that's a relationship between a reviewer and a book. You have also viewed. So anytime in my JSON, my meta book JSON, I have the also viewed field. It's not here in this case, but it's in some of the other data. I'll be creating an also viewed relationship. Same thing goes for also but by after viewing, right? So you can see that these are books. So let's take also but as an example. So there are 5 books here. So this means that I will create 5 extra books with this ASIN number, because remember that's the unique identifier. And then I will create a relationship also but between this book and the 5 books. So this will be 5 separate nodes, if that makes sense. So that's just a sneak peek into how you model graph databases, right? You want to be thinking about, or anticipating the relationships you would be having, and how to you then structure your database, obviously, so that you get the optimal results, right? Okay, so let's get into how to connect the database. So now I have the Neo4j desktop application open. And if you recall from the last video, I showed you how to create a remote connection. You just come to add and click on remote connection. I'm going to call this, let's just call this book graph. Let's say recommendation. Okay, recommendation. And now by default, you have this on 7687. Now within my Docker container, I have that on 7687. I'll show you. See if we can pull that up. Now, if you look at the Docker container, I have the YAML file. You can see where I've set up my Neo4j service. You can see that that's mapped to 7687. So that's why we have this as 7687. And that's on your local host, of course. So yeah, just click on next. And I also have a password. I'll just pull that up. I have my password. That's the password, and this is the username, Neo4j. Just copy that quickly. Copy that, and this is just password. Great. Let's see if this works. Then you can connect. Okay. Looks like it's active. Let's open it up. Okay, I'll just pull that here. All right. Great. So you're familiar with this. We looked at this earlier. Okay, so everything looks good. You could close this if you like. All right. Okay, so let's look at how to query more complex relationships, essentially. So let's say I wanted to query 2 relationships, let's say. So let's say I wanted to do like the also but and by after viewing. So essentially you could do the or. This is a logical operator, that's or. So we do a match. And I'll just copy this to save time. Okay, so what we're doing here is we're matching and we're saying fetch me the book, any book that's been also bought or bought after viewing this book. So you can see the direction of the arrow here, that it's pointing towards this book, which means this is the book we're looking for, right? We're looking for the books that have been bought, also bought, and but after viewing, pardon me, after buying this book. So it really matters what direction we're taking here, because if you recall, I showed you in the JSON, for a book that's bought within the metadata books, you can see that there's some sort of relationship. There are other books that were bought at the same time, or books that were bought after viewing this certain book. And those are 2 relationships which we've created. So we created a relationship from the book that was initially bought, or the book in question, to the books that were also bought and the books that were bought after viewing. So that's a relationship that goes from this book to the unknown book here. And that's why we have this direction. We could face it in the other way and say, start off with this and change the direction to face this way. Just bring this the other way. It would achieve the same thing. So I could just return BKS, and let's see what that gives us. Okay, now we have loads of books here. You can just zoom in a bit and see how this looks. Great, this is a really complicated web of relationships, which I'll not go into. But essentially what we're doing here is that we're querying for two different relationships. So this is the OR operator, which means it could be also bought or bought after viewing. So either way, it could be only also bought or buy after viewing, or both. You know how the OR operator works. Now let's try to extend this query a bit. So let's do that. So let's say we wanted to, for these books we've gotten, let's say we wanted to get their categories and subcategories for the specific books that were also bought or bought after viewing. So let's try to do that. So in order to do that, we can persist the variable BKS and make another match with that. So let's try that. So match, and now it brings up BKS for us. And now if you recall, there's a relationship called has category, right? Or is category, I should say. Let me just confirm that. Okay, I think it was belongs to. Let's check. Belongs to, okay, perfect. So belongs to, and we could say a category. So it's of the type category, of course. So belongs to this category, and then that category we said could have a subcategory, right? Has subcategory, and let's do, let's call that SC and sub. Oh, my bad. That should come up, right? Okay. Category. Let's just copy this, because a subcategory is also a category, of course. But this is what specifies whether or not it's a subcategory, if that makes any sense. Okay, so belongs to category, has subcategory. And then we would want to return, so we wanted to return the BKS, unique identifier. What else could we return? Let's return the category name. So we see that's still in variable C, and it has a property called name. So that's the name of the category. As let's say category name. Am I spelling that right? Category name, and let's have the subcategory. Subcategory name. Now, what this is going to do, if you're really familiar with SQL, you know what I'm talking about. So if there's one row if there's several rows rather for one category, that's because it has many subcategories. So say you had romance, and then romance had a subcategory called, say, fantasy. And then you had another subcategory for the category romance. Maybe, I don't know, I'm not really into romance stuff, but if you had another subcategory, that would be a different row. So if I was to query this like this, it would return as many rows as their subcategories for each category. So we could introduce a function known as collect. So essentially what collect does is it merges all the names together into one list. So let's just do collect, right? So collect sc.name as subcategory. Now we would say names because there will be more than one. All right, let's see if this works. Hopefully there's no errors. Great, we see that that works, but now we have duplicates. Looks like there's some duplicates in here. Okay, let's try to do a distinct. So we could just introduce distinct here to ensure that it's unique, distinct, and we run that. Great, looks much better. So now we have for each name, the ID, the book ID, we have the category name, and then we have the subcategories. All right. Now let's say we wanted to do a sort of left join where we're getting categories, we're getting books that don't have categories, because there are some books that haven't been assigned categories yet, and say we wanted to do a left join to include those books. We could just slightly change this and introduce the keyword optional. Optional matching, optional match. So optional match would say, so you first of all match this because this doesn't have optional. So you match all the books, whether or not they have categories. And when you do optional match, of course, on the left-hand side, you have the books. So if they don't have any categories, which means they don't match up with this relationship, nor this one for that matter, then you'll still return them. That's an optional match. Now, if you look at this, we have 15 records here. Let's hope we have more records in this case. Now we have 96 records. And there are lots of nulls in here because obviously there are no categories, no subcategories, if that makes sense. Now let's get into pattern matching or filtering. Let's start with filtering. So with filtering, you have the where clause, which is the main clause. I showed you that in the documentation earlier. So with matching, with the where clause, pardon me, you're essentially doing what you're familiar with in SQL if you've done any SQL. So with the where, you're trying to find where a certain variable matches up with something, or where a certain node is like this, or where a certain property has a certain value. So there are lots of things you can do with the where, like you'd see. We'll get into regular expressions and pattern matching. So let's say we wanted to get all the books that belong to the romance category. So you should be familiar with this already. So we get the book, create the relationship, or rather match the relationship belongs to. I'm not saying that belongs to a category. Now we can introduce the where clause. So where c.name, so the category name is equal to romance. It's pretty easy. It looks like SQL. Now we want to return the book or the books. And now, because this is a really huge database, I don't want this to sort of begin to lag. So I'm going to just limit this to, and this is the same keyword from SQL. So limit this to the top 10 or the first 10. So we have the 10 returned. You can see that in the table if you want to. So this is the data returned. All right. Okay, so let's say we wanted to do something a little more complicated. Let's try to do some pattern matching. So for all the books, we have books with titles. So let's say we wanted to get the books with titles like Spanish, because you know in SQL there's the like command where you have the percentage operator, and that helps you match patterns with where there's as many characters before and after a certain word. So let's try to replicate that. So let's do match. So I wanted to get all the books. All the books where, oh sorry, my computers, where be the title. Now in this case it wouldn't be equal if this first. Okay. So now with pattern matching, you could do, and I'll show you, if you look at the documentation, you should be able to see the full list of the different operations. But by doing this, We could put Spanish in here, and this. So essentially this says any character preceding, and this just says any number of characters. And star just sort of amplifies the effect here. So any number of characters after as well. The Spanish. So I want to return b.title as titles. I'll just adjust the space here. And this should say title. Let's do that quickly. Great, so now we see the various titles with Spanish in there. We have Spanish edition, Spanish is in here as well. Okay. Now let's try to do something else, and I'll just copy this and just explain that to you. Now match book where title is autobiography. So this, whenever you want to have two alternative words, so either of or by, you could put them in parentheses like this. So autobiography of or autobiography by, and then followed by a number of characters, what you're doing here. So let's run this. So see the titles, we have autobiography of a beggar boy, autobiography of a haunted priest, autobiography of, so there's no autobiography by, it seems here. But if that was to appear in this, if there was such a book with such a title, that should have been returned here. Now I'm just going to copy this and paste it here. Now what I want to do is to check for books that are classics, right? So I'm going to remove this and replace that with classic. Say classic with anything after, right? So now you can make this case insensitive by introducing this and just doing a question mark and I. So this essentially makes this case insensitive. And yeah, let's return the title. Great, so classical, 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 classic. Regardless of whether or not this begins with a lowercase or uppercase C, that should return. All right, so let's try to build out another query. Let's do something more complicated. I'll bring this up. Great, let's say we wanted anything that had, let's say children or child. And let's just take this away. So this essentially will give us child, anything prior and anything after. But now, what if that's children, right? So we want to do something optional. And the way to do that is you could add the additional text. So it could either be anything before or child. And then now want to make ren optional, just because this completes the word children. So we could just put a question mark here. So this essentially will say anything that has child with anything prior or before, with anything before or after. And then you could also have children because this is optional, and then anything afterwards. So let's try to see if that works. Great. Now we have, let's see if we have children in here. Okay, we have child, so that's great. So this essentially gives us things with children, gives us titles with children, and here we have grandchild. And that's fine because we're looking for anything that has to do with the child. Great. I know these aren't perfect examples just because that's how the database is. Couldn't control that. But yeah, I hope you're learning the concepts anyway. So let's do some filtering. So I'm going to show you how to filter for within values. Now I want to filter for a range of values. So which reviews happened between this Unix time and this Unix time. So this is really basic as well. So I have a reviewer here and they've reviewed, right? This is the reviewed. This is what I'm looking for here. Because essentially the Unix time, the time a review happened, exists within the review property, right? It exists as property within the reviewed relationship, which is why I've only given a variable to R here and not the reviewer, because I'm not interested in any property that has to do with the reviewer, if that makes any sense. So I'm interested in the relationship because the property, the time when the review was done, is more associated with the review itself as opposed to the person who has made the review. And I'm looking for books that were reviewed within this time. So you could alias a relationship, give that variable, and filter where that Unix time is between this, so that would be greater than or equal to this Unix time and this other Unix time. And then I could return the reviewed books, and you could get any properties of the books as well. You could do, give me the title. You can see that comes up. So you can play around with that as much as you want. So we have this returned. If you want to have the graph, feel free to do that as well. But the table gives you a pretty granular view, so that's always good. Great. Okay, now let's, how about we have some type of iterable or a list, right? And we're trying to find the occurrence. So instead of doing like where category is humor, or category is mystery, or category is thriller, we can shorten this to have the in keyword. And again, if you're familiar with SQL, you're definitely familiar with this. So we can match a book to its category and say where the category name is in this list. So either of this or all of these or a combination of this would work. So, and the reason I've put this flag here, a filter for B title is not null, is just so that we can have values to return, because there are some books that have no titles. So don't worry too much about this. But of course, if you wanted to have multiple conditions, then you definitely use the and keyword. You could do or as well. And yeah, let's return this. It's taking some time. So we have Merriam-Webster and we have, I don't know what this is anyway, but this is the result we have. So let's talk about predicate functions now. So predicate functions are essentially the Boolean functions that return obviously true or false for any number, and listen to this, this is really important, for any number of non-null inputs, right? So let's say we had an iterable. So look at this iterable here. So why is this an iterable? Or let's say a collection, right? In Cypher terms, this is a collection of category names which are non-null. So essentially what we're saying is that with a predicate function like all, we're going to check through the entire collection, and for each input the condition we've imposed here has to be true in order for this to return that object. I'll say that again. So each object is returned only if all, because this is the all predicate function, every element in the collection fulfills this condition. So there are lots of other predicate functions. You have none. So for none, if no item in the collection fulfills that condition. So that's also single. This could be single. And if it was single, then only one element should fulfill this condition. It could be any. So if any of them, so at least one of them fulfills this condition, then we could return that. So in this case, I'm going to do all. So essentially I'm saying all the categories for this book must be within this list. So you could have human entertainment, you could have mystery, you could have thriller, but if anything's outside of this, which doesn't fulfill this condition, obviously this will return a false, and there must be no false for all. So essentially look at this as returning a list of Boolean values. So you have true, true, false, true, true, whatever. If there's at least one false, this wouldn't be returned. If that makes sense. So predicate functions just help you work easier with iterables, let's say, or collections in Cypher. Helps you filter easily and check for, say, check for conditions being fulfilled or not being fulfilled within a large collection. That's what we're doing here. So you can look this up and read more on it. If you just go to the official Neo4j documentation, you should be able to read on this. So I'm going to run this and see how that works out. Okay, great. We have essentially some of the same books we had returned earlier, if you look here. But let me just explain this quite a bit, because I didn't touch on the with clause. So I was saying that if you had to persist a variable across many queries, usually you want to use the with clause. The with just says, I want to work with the B variable, which is the books that have categories, and then collect. We already touched on collect. It takes all the categories and puts them together into one collection, which means instead of returning different rows where you have books and categories, so instead of returning rows, as many rows as you have categories, what it's going to do is that it's going to return the distinct book and a list of categories, and then that makes for a collection, which we're then going to match and look for where all elements of that collection fall into this iterable, right? Fulfills this condition which is specified here. And this simply says for cat and categories, where category in this list, and then we want to return the distinct title and the categories. That's what we're doing here. So let's look to the right. We can see that these are the categories. These are the categories that fulfill this condition, and that's where I'm going to leave it today. So we've touched on quite a number of things. Just to recap, we looked at more complicated relationships where we could introduce logical operators to check for more than one relationship. We also talked about matching, what was this again? Okay, matching having several match statements together. And we also talked about, let's just see what this was, using the optional match, which helps us achieve left drawing capability. We also talked about filtering, basic filtering here, pattern matching and regular expressions. We did a couple here, and you can always go back to the documentation to look up other symbols and other regular expressions if you want to use them. And we also talked about filtering for multiple conditions using and you can definitely use other logical operators like or and not, of course. And here we just did some more filtering, and I showed you how to use the in when you're working with iterables. Yep, I think I'm going to leave it at that. There's lots more we could be touching on, but feel free to reach me in the chat in the comment section if you have any questions. If you're struggling with a difficult problem and you want me to help out, please reach out to me. Thank you so much for your time.